grading of cables. So what is grading and why it is required? Now if you remember the expression for electric stress, the electric stress G we wrote as Q by 2 pi epsilon x, where x is the distance from the center. This is the core and this is the distance x. Okay. Now where will the maximum electric stress be? You can see that G is inversely proportional to x. So maximum electric stress will be present when x is minimum, which is nothing but at the surface of the conductor. Okay. Therefore, at x is equal to r, this is the radius of conductor. You can even draw the sheath. So at x is equal to r, G has a minimum value, and at x is equal to capital R, this is capital R, right? So G will be maximum. Okay. So now why we are talking about the electric stress? The insulation here, this is what bears the electric stress, right? Now because the electric stress, it is varying with the distance, the insulator is going to face non-uniform electric stress. Is experienced by the insulator. So we don't want this, we want the stress to be uniform. For this very reason, we do the grading of cables. Now how is grading done? What is grading in fact? Okay. So there are two types of grading. Of cables, right? Grading of cables. So the first one is called capacitive grading. So in capacitive grading, what we do is insulators of different permittivities are used. So if you take the expression for stress once again, this is equal to Q by 2 pi epsilon x. This we want to be almost uniform. Okay. Now if you can write Q by 2 pi epsilon, if you can write the permittivity in terms of epsilon naught epsilon r into x, then it is better understood. Now what are these Q, 2 pi epsilon naught? These are all constants. They cannot be much manipulated. But what about this epsilon r x? These epsilon r is variable and x is the distance, that is anyways a variable. Okay. So in order to maintain G constant, if we can maintain epsilon r x to be constant, then we can get a uniform stress. Okay. So the permittivity should be the materials, different materials that we are using, those permittivities, they should be decreasing as we go from core to the sheath, that is from the inside to outside. Okay, innermost layer to outermost layer. Okay, so that is how you can maintain epsilon rx constant. The second type of grading is the inter-sheath grading. Here what is going to happen? The insulator will be homogeneous, that means the same insulator is used with the same permittivity, but in between there is going to be metallic intersheaths. Okay, layers of intersheaths are going to be present. So let us say this is the core, then one metallic sheath is used here, another metallic sheath is used here. Okay, so in between these layers there is going to be insulator. So these are the intersheaths, and these intersheaths, they are maintained at certain voltage. So let us say this voltage is at V. Okay, then this voltage will be at V1 and this voltage will be at ground. Okay, so in this way each of the intersheaths, they have different voltages that should be maintained. The voltages should be maintained by some other external means. Okay, so that is the intersheath grading.